Hi, my name is Xiling, and I'm one of the founders for the company MEQ and also taking the position as CTO in the company. In the year 2015, I earned my PhD degree in the area of mechanical engineering, focused very much on how to reduce the vibrations in metal cutting process. 2016, I founded the company MEQ together with my two professors, and 2018 we sold our first unit. In the year 2019, we started to have the serial production, and up to today, we have sold over 7,000 units on the world market. I have a genuine interest in scientific topics, and I have a vision to simplify machining for the operators who work in the shop floor. The challenge we were facing back in the days is that, as one example, if you buy two identical machines from the same brand and they get delivered to your shop floor in the same time, and they're just going to have two different performance when it goes to real production. There are several theories trying to explain the reason why, and what we are looking at is the vibration frequency in those machines. And we said the challenge was the varying vibration frequency during machining. As one example I'm showing here is a 20mm turning tool, and we put in the machine at different aperture ratios from 6 times the diameter, 8 times the diameter, and 10 times the diameter. And if you are able to measure the most prominent vibration frequency, you will realize that the vibration frequency of the tool actually change constantly when you change the L/D ratio. And that was the challenge we're looking at. The tool has a varying vibration frequency. If you have a fixed vibration frequency, it's relatively easy to find a solution because you just need to work against that particular frequency. But when your frequency is always changing, then you need a solution that can adapt or change itself when you have a change in the vibration frequency in your cutting process. The solution we're presenting today is a self-tuning mass damper technology, or called STMD, on the market. It composes a mass, usually made of a tungsten, which is quite heavy, supported by polymeric materials. And the unique feature for the solution is that it's made for immediate usage, meaning that you don't need to make any adjustment when you put it into the machine. And the damping mechanism inside the tool actually can adapt itself to the changed vibration frequency in your machining process. And the advantage coming out from the technology is that all of a sudden the tool equipped with the STMD solution actually has a much wider operation window compared to your previous products. So let's make a comparison with the most dominant solution on the market, and the STMD. So on the left hand side of the picture you see a solution where it also has a mass damper inside the cutting tool, and the mass is supported by rubber rings, and they have put the viscose oil inside the cavity between the damper and the tool to enhance its damping efficiency. If you take a close look at the rubber material and look specifically at its stiffness, it has pretty much a constant elastic modulus over the frequency range we are interested in. And on the contrary, what we have done comparing to the most dominant solution on the market is that we have taken away the viscose oil, so the solution for STMD is purely dry. There's no risk for leakage in the product. And we have replaced the rubber rings to the polymeric materials that we have in the STMD technology. These polymer materials has nanostructures inside them, which allows them to have a changing stiffness along with the frequency. So when your frequency is increasing in your machining process, these polymers, they get stronger and tougher, stiffer, so that you can change the vibration frequency of the damper to make a match. And when your frequency in the machining process is actually decreasing, then these polymers, they will get softer to make a fine adjustment of the vibration frequency from the mass damper to make a match. So all of a sudden you have a passive solution, but you have achieved an active function to make sure that your damper today is fine adjusting itself to make a match to your changed vibration frequency in your cutting process. If we make vibration measurement of the tools and we look at how much the tools will vibrate under an impact force, and here I'm showing the comparison results where I put a 25mm product into the machine and measure its vibration displacement along with the frequency. So the x-axis represents the frequency, y-axis represents the amplitude, the red curve represents the competition product, and the green curve represents MEQ product. And you can see that when we changed aperture ratio from 6 times the diameter up to 9 times the diameter, independent of the aperture ratio in machining setup, MEQ constantly achieve a lower vibration amplitude, between 25 up to 45%. And this actually means if you put the MEQ product into action during metal cutting, the MEQ product, the STMD technology, will have 25 up to 45% higher productivity. And we also learned that the competition solution on the market actually has their sweet spot, meaning that they are fine-tuned for certain frequency range. In this range, they have more or less the same performance compared to the STMD solution. But as soon as the machining condition move away from their sweet spot, then the STMD solution will show its strength. Adjust itself to make the fine-tuning, increase its damping efficiency, and get better results. And we have also learned in the past that the clamping of the tools is also critical when it comes to a challenging condition.
One question we often get when a new partner joins us is, where should we start to look? Who should we approach? Listening to our partners, we can give you some recommendation where to start. Aerospace industry has very strict tolerance requirements for parts used in airplanes and spacecraft, as well as high levels of accuracy. To achieve these requirements, vibration dampening tools are essential. The defense industry has always high requirements on surface finish, precision and tolerances, and you can definitely find need for Amaco tools and tool holders here. The energy industry is another sector that need vibration dampening tools because of the high requirements on surface finish and often complex operations. And then we have suppliers and sub-suppliers. Many companies in this sector meet very tough requirements and performs a wide variety of operations. They can really benefit from the flexibility that Amaco tools can offer.